Well, this is it, guys. This is where the full joy, or brackets terror, close brackets, depending on how you see it, of sine and cosine graphs unfolds before our eyes. So we've got to find x-intercepts and sketch the whole shooting match here in detail for graphs of sine and cosine. So gulp or oh joy, and let's get into it. Sketch the graph of each of the following for 0 to 2 pi. Clearly indicate axis intercepts. Well, we've got four beasties there three beasties there for us to do, and don't you worry, they will keep us busy. Alright, come on. Onward ever onward, intrepid as we are. Number A today. We've got this beast, right? Now let's have a look at a bit of a summary of it. Its amplitude is root 2, excuse me, wait a minute. That's better. And its period is 2 pi, a normal one, not fiddled with in the x department. And it's got a vertical translation of 1 unit upwards, okay? So far so good. Now here we go. I'm going to give you the recipe, and it is a comprehensive recipe about how to do sine and cosine graphs in a minute. NB, nota bene. When a graph is translated vertically, guys, the x-intercepts cannot be deduced by simple shifts to the left or the right of their untransformed values, as can be done with horizontal translations only. Okay? Horizontal translations are not so bad because you can just sort of shift everything to the left or the right because they are the same distance apart, the x-intercepts, in a horizontally translated graph. But if they're vertically translated, no, they are not the same distance apart, so they must be calculated by substituting y equals 0 into the equation of the graph and then solving for x, okay? So here's a step-by-step process for sketching, analysing and sketching sine and cos graphs. Alright, the first thing we must do, number 1, is deduce the transformations from the graph equation, which we've already done. Right, we've done that so far. So that's first cab off the rank done. Then you work out what I call the working domain. That is the domain in which we calculate the x-intercepts, okay, without overshooting. I just like to do it that way. You don't have to do it that way, but that's the way I do it. Otherwise you overshoot until you get out of range. I just like to work it out properly from square one. Now, a third thing we do is we work out I work out, and I recommend it to you, I work out what a quarter cycle span is for x. And then fourthly, I calculate the transformed starting point of this graph, because that's where I start from with my sketching. Then fifthly, I calculate the coordinates of the end points, and then I work out the x-intercepts and then the y-intercept, only one of them. And then what I do is I faintly draw horizontal lines on the graph for the central axis and for the upper and lower y limits of this particular graph. That helps me very much working out where I'm going with the sketching, okay? And if you do them in pencil, you can rub them out later. It's just that they give you a very good grid to work within. Ninth, now this is where the rubber hits the road now, the sketching. I start at the coordinates of the transformed starting point, and then I sketch the graph in quarter cycle segments. Okay, quarter cycle segments. That means, for example, from the central axis to the uppermost point, it'd be a quarter cycle. From the uppermost point back to the central axis, it'd be another quarter cycle, or from the central axis to the lowest point, etc. You know what I mean? And 10th point on the list is we check that all endpoints and x and y axes intercepts are appropriately labelled using their coordinates. And lastly, if this wasn't enough, we label the graph with its equation. Right. Well, it's a pretty long list, isn't it? But that's the way I do them. And fortunately, you're unlikely to get a really complicated vertically translated graph in an exam because they just take too long to work out if you're in a technology-free situation. Okay? Alright, let's go with this. And you're unlikely to get any graphs in to do like this in the technology-enabled exam because some schools have started using the software Mathematica, which enables them to do graphs in an absolute snap. Okay, so here we go again. There's the first one. That's the one we're doing. Let's go for it. The transformations, yes, we refer to the above analysis, which we're very pleased with because it gives us an idea of what this beast is doing. Working domain. All right. Well, the working domain for this one's very, very simple because the x has not been messed with. Okay, so it's just going to be. We're sketching it from 0 to 2 pi, so x will also go from 0 to 2 pi for this particular one, but it gets more complicated later on, as you'll see. Now, a quarter cycle span for this beastie would be pi on 2 because its period is 2 pi, right? The starting point when x is 0, oh yes, when x is 0, y won't be 0 because it's moved up 1, right? It's been moved up 1, so it'll be x is 0 and y is 1, so therefore that's our starting point. Okay, looking good. Number 5, the end points will be, x will be 0 and 2 pi respectively, and y will be 1 at each of those end points. All right, we got them sorted out. Terrific. The x-intercepts. Now, this is where we've got to work out the x-intercepts, guys. Now, this is not very straightforward because the thing's been moved vertically upwards, so we've got to solve it for y equals 0 into the equation of the graph. So that's what I'm doing there, and I'm solving it. I'm going to make sine x the subject. Sine x would be minus 1 over root 2, which tells us if our cast diagram's happening, we know that in quadrant 1 we'd be talking about a pi on 4 angle, but we're not talking about quadrant 1 because we need negative 1 over root 2. So which quadrants are we talking about? Yes, we're talking about quadrant 3 and 4. So we would be saying from the cast diagram the basic angle in quadrant 1 is pi on 4, but we want the angle whose sine is minus 1 over root 2. So therefore we want quadrant 3 and 4. So which are the angles? Yes, over the working domain, which is from 0 to 2 pi, we want, I'll show you, one in there, which will be 7 pi over 4. Oh, 5 pi over 4, sorry, and one in there, 7 pi over 4, right? They are the two x-intercepts, guys. So the x-coordinates of the intercepts are 5 pi on 4 and 0 and 7 pi on 4 and 0. Well, that's great. We've got that sorted out now. So that's what's next on the agenda. Oh, the y-intercept. All right, that's all right. We just set the x equal to 0 for that. And that will be y, let me see. Oh, yes, okay. If x is 0, sine x is 0, therefore that's all 0, therefore y equals 1. So therefore the end point, oh, well, of course it is. It's basically the y-intercept is the left-hand end point because it only goes from 0 to 2 pi anyway, so I didn't even need to work it out. Okay, you see? It coincides with the left-hand end point, which we've already worked out, okay, in step 5. Oh, here we go, guys. Goodness, this is the exciting bit. Now, that's the graph. Now, I'm going to show you how you would sketch that graph from scratch. That's the starting point, 0 and 1, right? Now, I'm going to go forth from that point in quarter cycle spans. Now, that's the upper limit, that's the central axis, and that is the lower limit there, all right? Now, okay, quarter cycle is pi on 2, so that gets us into perspective for us. Let's go for it. Okay, that's the first quarter cycle point on the graph, that's the next quarter cycle point, and that's the next one, and that's the last one, and so on. So we just have to fill in, you have to fill it in from this point to there, like that. And then you go from there to there, and you know what to do. It's a sine graph, so you know what you're doing. And that's it, guys. Now you've got to make sure everything's x-coordinates and are all put in, x-intercepts, I mean. That'll be there. That'll be 5 pi on 4, that'll be 7 pi on 4, and you've got to put your endpoints in, this one, and that endpoint's also the y-axis, so that's the x-intercept's done, that's the endpoints done, and the only other thing we've got to do is make sure we label the graph and put it there and point to it and everything, bells and whistles, all in place. Yeah? Mighty fine. Mighty fine. Right, number B now for you and me. Okay, what's this beast? What do we got? Y equals 2, cos 2x minus 1. Well, it's vertically translated, so it's a pain. Basically, to be perfectly honest, it's a pain. But what have we got? We've got an amplitude of 2, so it oscillates up and down away from its central axis by 2 units. It's got a period of pi, and it's got a vertical translation of 1 unit down, doesn't it? Now let's keep going. Yes, down. Transformations, well, we refer to above. We've worked out what they are. So yes, we've got a general lie of the land. And we've got to go from 0 to 2 pi. That's our domain. Working domain is going, if x is, yes, now here's where you've got to work out a working domain. See this beastie here? Okay, that's 2x. So we know that if x goes from 0 to 2 pi, which it does, they told us that up there, then we know that therefore 2x has got to go from 0 to 4 pi. So that is the working domain, ladies and gentlemen, that we must use, because this is cos of 2x, right? That's the working domain we've got to use to work out all our x-intercepts, okay? I'll show you. That's the working domain. Quarter cycle span is pi on 4 because the period of this beast is pi, isn't it? Starting point. Okay, starting point. Oh, yes. X won't be messed with, but Y will. So when X is 0, Y is 1. Because normally cos starts at its highest point, which would be 2. X is 0 and Y is 2, but this has been moved down 1. That's right. We've got it, guys. Now the end points. Okay, what you've got to do there is substitute X is 0 and X is pi, 2 pi, I mean, into there, and you will get these two end points. You will. Alright, we're cooking along very nicely here. What else have we got to do? X-intercepts. Oh, here we go. Now, that means we've got to substitute y as 0 into this. That's what we get there. Therefore, we're going to get cos of 2x is a positive this time, positive a half. There's our cast diagram. So there's where cos is positive, quadrant 1 and quadrant 4. What's the basic angle? Yes, it's pi on 3. Fills us with glee. Yippee! Basic angle in quadrant 1 is pi on 3. So therefore, what do we want, guys? What do we want? You tell me. We want quadrant 1 and 4, so what are the angles we're going to capture? Capture from 0 to 4 pi. You see, that's the working domain. So over the working domain, we would want pi on 3, that's quadrant 1, 5 pi on 3, which is quadrant 4, and then we add 2 pi to the first one, doing a bit of a leapfrog there, and then we add 2 pi to the second one, and we get that. Now, of course, this is 2x. This is 2x, right? So we've now got to solve this for just x. There they are, in all their glory, guys. They are the x-intercepts. Putting them in coordinate form, we get that stuff. All right? Looking mighty fine. Now we better do the y-intercept now. That's the y-intercept again, in this case, is the same as the left-hand end point, because that is the point at which the graph starts. So it would be 0 and 1. So we don't actually have to work it out in this case, but you would if the left-hand end of the graph wasn't on the y-axis. Yeah, but it is in this case. Here we go. Here we go. Starting. Oh, there's the graph now. But that's like cheating. The computer worked it out, but we're going to work it out as if we didn't know that that was the graph, right? So there's our starting point, 0 and 1, right? There's the. Now we're going down in quarter cycle spans. A quarter of a cycle, remember, was pi on 4, wasn't it? So there, and there. Now that's how I'm going to sketch this graph, in quarter cycle bits. Now, cos goes, you know, it's the same old routine. We're starting from the highest point, so the first bit will be from the highest point down to the central axis, like that. And then from there, in quarter cycle bursts, as I've showed you. There's one, there's one, there's one, there's one, there's one, there's one, there's one. All right? Now that's not the end. We've got to get all the x-intercepts all labelled, all endpoints labelled, and the graph labelled, right? So there's one, what's that? Oh yeah, that's an x-intercept, that's there. There's an x-intercept, x-intercept there. There's the next one, there's the next one, right? As we work them out within our working domain. Okay, what's next? There's an endpoint, there's an endpoint. I think the only thing left for us to do now is to label the graph, make sure it's labelled and pointed to. That's probably not absolutely necessary, but I always do it anyway, just to make sure, in case you've got a grumpy examiner who's looking to take marks off you, which you don't want to give him that opportunity. Do you? No. Right, third one. Okay, now this looks pretty beastly, doesn't it? Gurky. Fear not, my children. We will reign and conquer. What have we got to do with this? Let's work out the summary. This is the amplitude is 2, period is pi, y is at pi. Well, we know because sine and cos love pi. They're related to pi. This has got a horizontal translation of pi over 3 units to the right, and it's put down by root 3. Right, that's got a bit of a summary. In other words, they've thrown the book at us. We're still going from 0 to 2 pi though. 0 to 2 pi. So I suppose we better work out the transformations we've done. I suppose we better work out a working domain. Right. Working domain. So if x goes from 0 to 2 pi, I'm going to work out what all this stuff that the x that's been messed with is 2 times open bracket x minus pi over 3 would go from starting with and ending up with, you know, like the domain thingy. So I'm going to work up to from the x equals 0 to 2 pi what 2 times x minus pi on 3 would go from and to. There it goes. There's the first step. Okay, so what I'm doing is I'm subtracting pi on 3 from the 0, and I'm subtracting pi on 3 from the 2 pi. Now I'm going to multiply the whole thing by 2. There it goes. Now that, ladies and gentlemen, is my working domain within which I'm going to capture my x-intercepts. Okay, quarter cycle span is pi on 4 because the what am I trying to say? The period of this thing is pi. The starting point is, well, that's the starting point for x is going to be when that whole thing, in other words, everything behind that sin, sine, is 0, right? Because sine of 0 is the normal starting point, right? Yes, so now we're going to solve that for x, guys. Therefore, x is pi on 3. Of course it is. So that's going to be the starting point for x, but what would be the starting point for y? So when x is pi on 3, y would be that thing. Oh, right. Easy from the equation. So it looks like the starting point is pi on 3. Yes, pi on 3 and minus root 3. See how easy it is when you do it all systematically. Now, all right, next on the agenda, endpoints. We've got to substitute x is 0 into this, and x is 2 pi into that, and work out the respective y values, and that'll get the coordinates for us of the both left hand and right hand endpoints. That's the x is 0, 1. Apparently that, yes, well, just trust me, will you? Comes out to be minus 2 root 3. And when x is 2 pi, I think it comes out to the same thing. It does. Righty-ho. So the endpoints are those little coordinates. Yes, looking good. So we've done that. Now what are we got to do? X-intercepts, right. Okay, I told you this. I told you this was mind-bending. When y is 0, we've got to solve it for when y is 0. What am I saying? When y is 0. Oh yes, I've just basically rearranged the equation a bit. That's right, so I've got to basically proceed forth. Yes, this gets us our cast diagram. So when sine, there's the basic angle. When sine is root 3 over 2, it would be pi on 3. We want positivity here, so we want quadrants 1 and 2. So let's see, we've got to work within this working domain, guys. This working domain to capture whenever you have the equivalent angles in in this quadrant 1 and 2, going backwards. First of all, going backwards down to round to minus 2/3 of pi, as indicated over here, and then going forwards from this point round to 10 pi on 3, which is, what's that, 3 1/3. So it'll be right around here once, then around to again another one there, pi on 3. I think that works. Let's see. In quadrant 1, yes, in quadrant 1, I got a bit ahead of myself there. The angle whose sine is root 3 on 2 is pi on 3. So therefore we want quadrant 1 on 2. 1 and 2, yes we do. So over the working domain, ladies and gentlemen, no solutions going going in the negative direction, right, from 0 back to minus 2 pi on 3, because that only gets you round to there, and there's nothing there. So looks like we're going to get all our solutions from going in the forwards direction as far as 10 pi on 3, yeah? We better have a look at this. In the positive direction, yes, from 0 to 10 pi on 3, there was our cast diagram, just recapping. So therefore, we'd say that whatever was behind that SINE, sine symbol, you would get 2 times x minus pi on 3 would be pi on 3, or 2 pi on 3, that's quadrant 1 and 2, then add 2 pi to the first one, and add 2 pi to the second one. Yes, that's right, guys. Now, if you go any further than that, you're going to basically have to add 2 pi to this one, which would get you 13 pi on 3, which would be too far. See how valuable the working domain is? It's really cool. So, okay, now, having got all this stuff, now we have to solve this for x, right? So we better divide both sides by 2, and now we better add pi on 3, which is 2 pi on 6, to every one of those terms to solve it for x. All right, you're still with us? Hello? Wake up! So, right, pi on 6 plus 2 pi on 6 is 3 pi on 6. I haven't simplified them down yet. 2 plus 2 pi on 6 is 4 pi on 6. 7 pi on 6 plus 2 pi on 6 is 9 pi on 6. 8 pi on 6 plus 2 pi on 6 is 10 pi on 6. Oh, pi everywhere. That's simplified there. That's simplified there, right? I've simplified them down by cancelling top and bottom where possible. So therefore our x-intercepts are, roll the drums, this, and this, right? Okay. Now, goodness. Here we go, y-intercept, well in this case, oh that's easy, isn't it? The y-intercept is the same as the left-hand endpoint because we're only going from 0 to 2 pi, so that's a blessing, isn't it? So that's going to be that because we already worked it out in I think it was step 5. Here we go, guys, here we go, the big finale. Now, that's the graph, the cheating version, the computer-generated version, but I'm going to start from, I've done all my 3 horizontal lines. That's the central axis there. It's been moved, where's the x-axis? Oh, there. So this has been moved down by root 3, and then it oscillates 2 units either side. So that's minus root 3, minus 2, minus root 3, plus 2, which gets you just above the x-axis. So these little bits here, 1, 2, 3, 4, are the x-intercepts. So that's looking pretty good. We did get 4 x-intercepts, so I'm encouraged. Okay, what's all that? That's my starting point. That's my starting point. Yes, remember I worked that out, didn't I? Alright, so now I've got to work out where my quarter cycle steps are. I mean, it's easy to see here, but you haven't got the graph if you're doing it from scratch to work with, so you've got to work out where they are. So what you do is you go like that, up to this upper line, a quarter of a cycle on, in terms of x, from this point here, from pi on 3. Then you do another one, back to the central axis, to the lower axis, to the central axis, to the upper axis, to the central axis, and then you don't quite get to the end, to the lower axis again. Okay, because the things are all skew with because it's been moved forwards by pi on 3. So now what are we going to do now? There. Okay, I'm sketching it. So from here we're going a quarter cycle up. Next one, next one, next one, next one, next one. Now that's the incomplete quarter cycle, but you know where the end point is anywhere, so it's easy to draw it from this last little leg here to there. Good. Now let's go the other one, going backwards from our starting point. That's that leg there, and then this tiny little teensy-weensy bit here to match the bit that's missing off this end. Okay, yeah, that's it. Now, okay, we've got the dreaded the dreaded beast drawn. Now we've got to get all our intercepts and endpoints and everything else all singing and dancing all over the place. That's the first x-intercept. That's the second x-intercept. Third one, fourth one. Cooking along beautifully. Endpoints now. That's one of them. That's the other one. And all I think we've got to do now is basically label the function, the equation. There it is. Oh my goodness, what a beast. Well, we did it, didn't we? We absolutely rocked along. So you can do that too. If I can do it, you can do it. I can promise you that. I think that's the end. The end is your friend in this case, and you're a star. and you'll go far if you practice, all right? Go forth, my children, and multiply your circular functions if you can bear it, and we'll see you next time.